In our quest for measurement of length so far, we have explored 4 key devices. These include meter rule, measuring tape, vernier calipers, and micrometer screw gauge. The use of device is dependent upon the magnitude of length being measured and least count of that particular device. So if a length is greater than 1 meters or 100 centimeters, then measuring tape is a suitable instrument. This is particularly true for uneven or curved surfaces, such as circumference of your waist. If the length is between 5 centimeters and 100 centimeters, then meter rule is an appropriate instrument. This can be used for measuring the length of regular shaped objects, such as length of your phone cover. The minimum length measurable by meter rule and measuring tape is 0.1 centimeters or 1 millimeter. If the length is between 1 centimeters to 10 centimeters, then vernier caliper can be used. The external jaws are useful for measuring the diameter of objects such as beakers. It can measure lengths up to 0.1 millimeters or 0.01 centimeters. If the measurable length is less than 2 centimeters, then micrometer screw gauge is a suitable instrument. It can be used to measure the diameter of a wire and can measure lengths up to 0.01 millimeters or 0.001 centimeters. It is important to remember the suitability of each device in different circumstances. Least count is the minimum value of length that can be determined by an instrument. Though the value varies, there is a trend across 3 key devices. Much like the waterfalls on the right, there are 3 levels of values that you need to remember. At the very top is meter rule, whose least count is 1 millimeters or 0.1 centimeter. Next is the vernier caliper, and its least count is determined by dividing the preceding value of least count by 10. In our case, the previous value was 1 millimeter or 0.1 centimeters. So dividing by 10, least count of vernier calipers is 0.1 millimeters or 0.01 centimeters. After that is micrometer screw gauge, and its least count is again determined by dividing the previous value of least count by 10. In our case, the previous value was 0.1 millimeters or 0.01 centimeters. So dividing by 10, the least count of micrometer screw gauge is 0.01 millimeters or 0.001 centimeters. Parallax error occurs when the position of eye is not correct. So instead of obtaining accurate value, we see an apparent length of the object, which is inaccurate. This type of error affects readings taken from any device as long as the position of eye is not perpendicular to the measuring scale. In this case, we have a coin placed next to the meter scale. When the eye is correctly positioned perpendicular to the scale, the value measured is 81 millimeters. This is the correct position and is marked by the black dotted line. If we view the coin slightly below this position, the line of sight makes an angle with the measuring scale and is not perpendicular. In this case, the line of sight shows a value of 86 millimeters, even though correct value is 81 millimeters. The image appears larger by 5 millimeters. If the coin is viewed from a slightly raised position, then again line of sight is not perpendicular to the measuring scale. This is evident by the angle it makes with the scale, which is not perpendicular. In this case, the line of sight shows a value of 76 millimeters, even though the correct value is 81 millimeters. The image appears smaller by 5 millimeters. The next type of error is zero error, which affects readings from both vernier calipers and micrometer screw gauge. Zero error can be both positive and negative. However, it might be difficult to remember if a particular value is positive or negative. Moreover, if it is to be added or subtracted. Hopefully, you will find the following analogies in later sections useful in remembering the type of zero error occurring. First, let's draw a number line with zero mark at the center. The zero mark is marked by black dotted line. Numbers to the right represent positive integers, while numbers to the left represent negative integers. The thing to remember in zero error is that if a particular scale is to the right of reference mark, then it's positive zero error. This means the device is showing extra length than it should. Therefore, it must be subtracted from observed length to get actual length value. Conversely, if the particular scale is to the left of the reference mark, then it's negative zero error. This means the device is showing less length than it should. Therefore, it must be added to the observed length to get an actual value. Just to recap, anything right to the zero mark must be positive, while value to the left represents negative. Let's apply this analogy to vernier calipers. We know vernier calipers has two scales, main scale and vernier scale. Vernier scale is free to move. In this case, main scale is represented by red lines, blue lines represent the vernier scale. Ideally, when the jaws are closed and there is nothing between them, then the zero digit of main scale should coincide or overlap with the zero digit of the vernier scale. This shows that the device is measuring no length. However, this is not always the case, as the device can become faulty over prolonged use. In the first instance, the vernier scale slides to the left of the zero digit on the main scale. Since the vernier scale is to the left of the zero digit, we can conclude that this is a negative zero error. Remember our number line analogy. This value must be added to the observed length as the device is measuring less length than it should. In the second instance, the vernier scale slides to the right of the zero digit on the main scale. Since the vernier scale is to the right of the zero digit, we can conclude that this is a positive zero error. Remember our number line analogy. This value must be added to the observed length, as device is measuring more length than it should. Just to recap, anything right to the zero mark must be positive, while value to the left of the zero represents negative. Let's apply this analogy to micrometer screw gauge. Micrometer screw gauge has two scales, main scale and thimble scale. Thimble scale is free to move. So when the jaws are closed and there is nothing between them, then zero digit of the thimble scale should coincide with the reference line of main scale. This is clearly not the case, as the zero digit is below the main scale reference line marked by yellow lines. The micrometer has become faulty. To visualize this better, we will flip the micrometer such that the U frame is at the bottom while the ratchet is at the top. In the first instance, the main scale reading is marked with red and zero digit with white dotted line. In this case, the zero digit of thimble scale lies to the left of the reference line. Remembering our number line analogy, this is negative zero error. The value must be added to the observed length as device is measuring less length than it should. In the second instance, the main scale reference line is again marked with red and zero digit with white dotted line. In this case, the zero digit of thimble scale lies to the right of reference line. Remembering our number line analogy, this is positive zero error. The value must be subtracted from observed length as device is measuring more length than it should.